Assalamu alaikum. In this video, we are going to discuss about Muller method. In our class, we have seen a little bit of glimpse of how Muller method works. In this video, we are going to discuss the same thing, but a little bit in details. If you remember, in our class, we have discussed that Muller method is pretty similar to secant method. And in case you have forgotten how secant method worked, let us go through it again. And in any of the numerical methods that we have used so far, the main idea was to calculate or locate any root of a given function. In second method, for example, this is f of x is given to us. Our target is to find the root. In second method, what we did, we started with two approximated value. Here we can see that we started with two approximated value x0 and x1, and then we calculated the corresponding output on the function. For x0, we would get f of x0. For x1, we would get f of x1. In this way, we would locate 2 points on the function. And then the next step was to connect those 2 points. And as you know, connecting 2 points means we will create a straight line. Here is the straight line that we have created, and then our next task is to find out where the straight line intersects in the x-axis. So that will be our next approximation. And in this way, we will keep running the loop and try to converge to the point where the root lies. So this is how secant method works. The, the difference between the secant method and the Muller method is that in Muller method we would be given f of x. Our main idea would be to find the root that is intersecting the x-axis. But unlike the secant method, in Muller method we will start with 3 points. And another difference is that we will assume that those 3 points are going through a parabola. And what is the advantage of this thing? Because we know the basic equation of parabola is ax square plus bx plus c. That means it's a quadratic equation. If we solve the quadratic equation, it is possible to get even complex roots as well. So the numerical methods that we have used so far were not able to give us any complex root. But in Muller method, there is a possibility that we might get to see a complex root here. Okay, let's go back to the basics of the Muller method. We will start with 3 points. Here we can see that f of x is given. We will start with 3 points x0, x1, and x2, and correspondingly we will find the output on the function, that is f of x0, that is f of x1, and f of x2. And then the next step is that we will assume that a parabola is going through these 3 points. Then we will have to find out the equation of this parabola. And if we solve that equation, we will find the 2 points where the parabola is intersecting the x-axis. One is available here, and another one is available somewhere here. So depending on the condition we get, we will replace one among these 3 points, and then settle our new three approximated values, and then we will run the calculation as like we have done in our secant method. Here we started with x0, x1, and x2. If we take this blue point as new approximation, then we will replace our x2 as this new point, and x2 would be replaced by x1, and x1 would be replaced by x0. In the same way, we will run the calculation again, we will run the loop, and then again we will get a new iterative point. So in this way, the loop will continue and it will give us uh, it will hopefully it will take us towards the root, and if any complex roots are available, we may be able to find that using this Muller method. Now let us go through the in-depth theory of the Muller method. The main idea here is that we will start with 3 points x0, x1, and x2, and we will find out the corresponding output of this x0, x1, and x2, namely f of x0, f of x1, and f of x2. We will consider a parabola that is going through these 3 points. So the main task here is to establish the equation of the parabola. Here is the equation of the parabola that we are assuming uh, is going through these 3 points x0 f of x0, x1 f of x1, x2 f of x2. Why the parabola is chosen in this way instead of ax square plus bx plus c? I think I have discussed it in our regular class. Okay. Uh, we will also be able to find out why this was important in a few moments. This is the equation of the parabola that we have assumed to be present, that goes through these 3 points. So now our task is to complete this equation. To complete this equation, we will need the value of a, b, and c. If we anyhow can find out the values of a, b, and c, that will give us the complete equation of this blue line or the parabola. And if we get the equation of the parabola, then we can easily get this estimated root. Okay. Now let us start our journey how we can find or complete the equation of this parabola or find the values of a, b, and c. So it is evident that this is the equation of the parabola of or the equation of this blue line, and x0, x1, and x2 falls on this parabola. So for the very reason f of x0 is this and f of x0 is a part of parabola, so we can replace the x by x0, that will give us the value of f of x0, and that is this equation. In the same way, we can say that x1 falls on the parabola. So f of x1 is this point, and if it is evident that it is on the parabola, so we can replace the x by x1. That gives us this equation. In the same way, we can replace x by x2. That gives us this equation. Now, look here. If we replace x by x2, we can discard these two quantities. That results in f of x2 is equals to c. We were to find three unknowns. One unknown is now at our hand. So that is the reason why we assume the equation of the parabola to be of this order. Now we are left with another task, that is we have to find out the value of a and b. So far we have three equations in our hand. The equation 1 is this, equation 2 is this, and equation 3 is this. And we already know the value of c. If we do the subtraction by 1 minus equation 3, this is what we get. And if we do this subtraction, this is the equation we get. So the process that we are going through is the process of finding out a and b. Please remember that. In order to find the a and b, we have done this subtraction and we have found these two new equations, 4 and 5. To make things easier, we will assume four known quantities here. These four known quantities will be h0, h1, delta 0, delta 1. Okay. Why these quantities will be known? Because we will start with x0, x1, and x2. These 3 points are known to us. And obviously, we know the values of f of x0, f of x1, and f of x2, as we will be given the function, and we will be we will be able to easily find out the values of f of x0, f of x1, and f of x2. So that being said, these four quantities will be known to us from the given information that that will be in our hand when any numerical problem will be thrown to us. So at this moment, we have these two equations at our hand, equation 4 and 5, and we have made these four known quantities, or we have created these four known quantities to keep this calculation simple, or make this calculation simple to find out the value of a and b. Our ultimate goal here is to find the value of a and b. Okay. Now remember, at this level, we have these two equations at our hand, equation 4 and equation 5, and these four known quantities. We know the values of these four quantities. And using these things, we will try to reach to a point where we can calculate the value, or we can extract the value of a and b, so that we can establish the equation of the parabola. So these are the known quantities at our hand, and this is equation 4 to begin with. So these are the four known quantities in our hand, and this is equation 5. Let's see how we can rearrange this equation in terms of these known quantities. At the left hand side, we can take minus outside, and in the inside the bracket we can write the same thing as f of x2 minus f of x1. And then this same quantity can be rewritten as this. So we have just brought x2 minus x1 beneath this f of x2 minus f of x1 and multiplied the same thing here. So that being said, this whole mathematical uh, object or term is equal to this thing. Now look here at the reference point. Can we replace this thing with any of our known value? Obviously, we can do that. We can replace this part by delta 1. This is delta 1. So we have replaced this part with delta 1. And we can replace this part with h1 as this is our h1. Now look at the right hand side. This x1 minus x2 whole square can be rewritten as x2 minus x1 whole square. And we know that x2 minus x1 is h1. So this quantity can be rewritten as this. Again, if you look at this quantity, it can be rewritten as this. And if we move forward further, this is how we can rewrite this quantity. So in total, the equation 5 can be rewritten in this format where this delta h1, 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 these things are known to us from the question or the mathematical problem that will be thrown to us. As these are known quantities and we have converted this equation 5 with in terms of our known quantities. Now our task will be to convert the equation 4 into same way. These are the four known quantities and this is the equation 4. Now we will start with left hand side. In our left hand side, we can initially rearrange our equation in this way. Further, we can rearrange it in this way. If you do the calculation, it will reach here, and from here we can reach here. Why we have done this? Because our goal is to convert this equation in terms of these known quantities. Now look here at this stage. This quantity is actually delta 1 and this is h1. This quantity is delta 0 or delta naught. This quantity is h naught. So we can replace them by our known values. So this is what we get at the left hand side of this equation. Now we are interested in looking at the right hand side. The right hand side can be rewritten. This term can be rewritten as this. And then we can rewrite this part as this. As from the given reference, we can see that x1 minus x0 is h0, x2 minus x1 is h1. If we look at this term, it can be rewritten as this, and further it can be rewritten as this. So that makes the equation number 5 to be of this order. Here, the unknown quantities are A and B, and all these quantities are known to us. Eventually, we are now at a point where we have this equation, the changed version of the equation 4 and 5 in terms of our known quantities that are used here as coefficient of our unknown quantity A and B. Remember, our main goal here was to find out the value of A and B. Here, we have reached to a point where this will look like a simple equation of A and B. Two equations are here with us. We can easily solve these two equations to find out the values of A and B. If we move further, this is the solution of A and B. and the value of C we have found out at the very beginning. So in your exam, all these things will be given to you. So here, why the discussion is done? Because to let you know how this thing has come into existence. Uh, so that is the main idea, to let you know. So we started with our mission to complete the equation of the parabola. And to complete the equation of the parabola, we would need the value of A, B, and C. The value of C we have found at the very beginning, and after doing a lot of mathematical, after having a very hectic mathematical journey, we have reached to a point where we can say that the value of A will be this and value of B will be this. Here, these quantities are known to us. So, since these are known to us, we can easily calculate the value of A, B, and C and plug them into here. That will be the equation of the parabola. So the equation of the parabola will be a quadratic equation, and solution of this equation will give us our next iterative value. Here is a catch, that the regular solution of the quadratic equation won't be used here, as we would love to compare between the newly found iterative value and our previously estimated value. So there is an issue that arises for round off error. So here, the general convention is that we consider our solution in this way. So this is one unique proposition here. We will consider that our newly estimated value is equals to x3, uh, which is calculated from our previously estimated value, plus our solution will be in the inverse order. Now here is another catch. If we look here at this part, which value we will consider, the plus or the minus? The main idea here is that we choose our value plus or minus in such a way the denominator here becomes the larger. If choosing plus gives us larger denominator, we would choose plus. If giving minus gives us a larger denominator, we will choose minus. In this way, we can reach to a point where we get our next iterative value x3. After we have found out the x3, how we will take the decision, or what will be our next step? So here you can see that if the real roots are being located, we choose the two original points that are nearest to the new root, estimate 3. If both real and complex roots are being evaluated, a sequential approach is employed, that is just like the second method, x1, x2, x3 takes place of x0, x1 and x2. So for our case, we will always go for the second strategy. So that was the basic discussion of how Muller method will be applied into mathematical problems. The whole discussion was to give you a theoretical idea why these problems are solved in this way. In reality, solving any problem using Muller method is very simple, since you will be given all the values and you just have to plug the values into right position to get the result. You do not have to remember the proof, but you have to keep in mind that how these things have come into existence. Now we will look at one example of problem that has been done using Muller method. So here one equation is given, f of x is given, and you are asked to solve it using Muller method with initial guesses of 3 points. As we know, in Muller method we will be given 3 points, or we have to start with 3 points. So now our task is to determine the root of the equation. The theoretical part that we have seen, to get to the solution or the root of the equation, we need to form the equation of the parabola. To form the equation of the parabola, we will need the values of a, b, and c. And to get the values of a, b, and c, we will need these four known values: h0, h0, delta naught, h1, and delta 1. From the information that we have here, we can calculate all these things here at once. After we have all these things in our hand, we can go ahead to calculate the value of a, b, and c. Once we have the values of a, b, and c, we can have the value of next iterative point. So this is how easy the method is actually in real while solving the problem. Even though the theoretical part might not seem easier on the easier side, but using these equations, solving any math will be quite easy. Here in this problem, they have found out the x3 to be 3.974, and they have replaced one root, estimated root, by this, and they have run the loop again and again to reach to a point where they get to a solution of 4. So that was our strategy number 2, and this is how we will be solving our maths if we are given any problem to solve using Muller method. So that was our whole discussion about Muller method. Thanks for listening up to this. Thank you very much.